Okay, again, this is sum or difference identities. So there's a couple of these formulas. If you look at the back of your unit circle sheet, it doesn't use A's and B's. It uses like alpha and beta. So if you want to rewrite these, that's always allowed. I don't have it opened up right now. Let me go find it. Trig sheet, maybe? No, that's the... But it's in pre-cal. Okay, so it is over here under sum and difference formulas. So you can see that it uses A and B, but it uses alpha and beta. Okay, but it still follows this same stuff that I've got written on your notes. The only difference is I've split it up. So you can see I've got two cosine formulas, and they've only got one cosine formula. But that's because they've used these symbols. So my plus has a minus right here. My minus has a plus right here. So with cosine, we're going to do the opposite sign. So if the problem has a plus in it, we're going to do the minus in the formula. Okay? With sine, it's got the same one, right? This is a plus or minus. This is a minus, or this is a plus or minus. So they're the same. Okay? What we always say is sine is the same sign. Sine is the same sign, and then cosine is different. Okay? So let's switch back over to the notes and talk about what that actually means. So here's our two formulas for cosine. Again, they're exactly the same except for the symbols. Cosine formula starts with two cosines and ends with two sines. Your letters are always going to go AB and AB. Again, you don't have to have it memorized, but it does speed things up if you at least know which one starts with two cosines. Two cosines starts with cosine. Okay? Another thing that confuses people a little bit is this is not the formula. That's the problem. And then you use that problem to plug it into the formula. Okay? Okay, so let's talk about what that means. Oh man. Does yours have something next to cosine? The one's downloaded? Does it have it?
No.
Dang it. Hold on. I think I have it on my completed notes then. That means it's probably a fraction or something. Yeah, okay, I've got it. Okay, so first let's look at cosine though. Cosine of 15, I mean. So what we need to do is we need to figure out how to find cosine of 15. Well, if you look at your unit circle, do we have 15 on your unit circle? No. We have to find something that gets to 15 on our unit circle by adding or subtracting. Okay? What I recommend is try to use this quadrant 1 as much as possible, because then we're dealing with all positives of everything. So how can I get to 15 using these degrees?
45.
You can do 45 minus 30. You could do 60 minus 45. There's actually endless possibilities, because it doesn't say that you have to stop at 2 pi. You could do 380 and 405. Like you could do however many circles around the unit circle as you want. I recommend going with the smallest ones that are in the first quadrant if you can. So we're going to rewrite this. Instead of writing 15, we're going to write cosine of 45 minus 30. Okay, again, you can choose anything. You could have gone down here and done 240 minus 225, but then you're dealing with that negative quadrant, and that's harder on us. So let's try to stay in this positive quadrant. Okay, so now that we've got that, I'll leave it over to the side, we can use our formula. Our formula is cosine of A, and A is our first number, so cosine of 45, cosine of B, so that's our second number. Cosine is the opposite symbol, so now it's a plus because we were subtracting. Sine of A, sine of B. Okay, this is something that would be on a no calculator portion. Okay, now now that we've split that up and written it in this formula, it does have stuff on the unit circle. So if we look at our unit circle, my marker. If we look at our unit circle, we can answer all of this stuff. What is cosine? What is our x of 45? Our x value of 45 is root 2 over 2. So root 2 over 2. What is our cosine of 30? What's our x of 30? Our x value is root 3 over 2. And we're multiplying that. Then we're going to add our sine of 45, or y of 45 is here. Our sine of 45 is root 2 over 2. And then my sine of 30, my y of 30 is 1/2. And we're multiplying those as well. So, just like with PEMDAS, we need to do our multiplication before we do our addition. We can multiply inside kids times inside kids. So, 6 under the root, and then 4 on the bottom, plus root 2 over 4. It already has a common denominator, so we can put them all over the same thing. So my answer is root 6 plus root 2 over 4. And that's my answer.
Why would you combine 6 and 2?
Because they're different. That's like an x and a y.
You're adding them.
Yeah, when you're multiplying them, you can do that, but not when you're adding. They're not. Same thing with fractions. It's like it doesn't have a common denominator, right? It doesn't have a common radical. Okay? Just for the record, all of your answers for these type problems will end up looking something like this. Because we're always using these numbers. Right? So they'll always end up looking like this. My denominator will always end up being a 4 because there's no other denominators besides 2 times 2. Okay, so they'll always end up looking like this. The things that could change is a plus here, change to a minus, or you can make this negative instead of positive. Okay, but it all will end up looking like a 6, a 2, and a 4 over and over again. All right, next. I'm going to write this one down for you. I give it to you this way. 5 pi over 12. Okay, there are 2 ways to do this. One is to use man, I'm blanking on that. What do you call that measurement? Not degrees, radians. That's it, radians. Okay? You can use the radians, or you can convert it to degrees. We've learned how to convert it to degrees. Okay? We can do it either way. So you can figure out 2 things that add up to get this with your radians on the unit circle, or you can convert it. I think the best way for you guys would be to convert it. Okay? Because it's kind of hard to figure out fractions that add to get this. By the way, if you did, it would be 2 over 12 plus 3 over 12. Because both of those simplify to our unit circle. However, I want to convert this instead. How do we convert? We multiply by 180 over pi. So that's now cosine of what? My pi's cancel. What's that? 5 times 180 divided by 12. 75? Okay, so is 75 degrees on my unit circle?
Yeah.
No.
No.
75 degrees would be right here, right? Between 60 and 90, right? That's not there. So we can't do that. We have to figure out something that adds or subtracts to get it. We got 2 easy things that adds to get 75. What about 30 plus 45? So cosine of 30 plus 45. There's my A and my B, and then it turns into the exact same problem as the other side. So I want you to finish out that problem. Use a unit circle, multiply, and then combine. Okay, so there's my formula written out. Remember, it was a plus, right? We were adding, so this one's going to have a minus in between this time. And then we go back to our unit circle. The x of 30 is root 3 over 2. The x of 45 is root 2 over 2. We're multiplying those, subtracting the sine of 30. The y of 30 is 1/2. The sine of 45 over 2. And so you can see that if you did use something in the other quadrants, these would end up being negatives. And so it still would work. It's just you would have a chance to make a mistake with a negative, which normally leads to mistakes. Inside kids, work with inside kids. So root 6 over 4 minus 1 times root 2 is a root 2 over 4. So you can see that this looks almost identical to our other problem, except for our symbol.
Why do you subtract?
Because we added in our problem, so we subtract in our formula.
Opposite.
With cosine, it is the opposite.
With cosine.
Sine is the same sign, cosine is the opposite. Okay? So hopefully you're thinking this is a lot easier because it's just plugging into a formula and reading your unit circle. Okay, so another way they could ask that totally confuses people is they give you the formula and ask you to figure out the original. They're asking you to figure out the problem here. Okay, so they gave us a formula. This formula starts with cosine, cosine. That means that it is a cosine formula. The other one doesn't start with cosine, cosine. So this is a cosine formula. Because that is a minus, what are we going to do with our degrees? We're going to add them because cosine's opposite. So we're going to take 87 plus 93. Cosine of what? 180. And now you tell me what the cosine of 180 is. So going on our unit circle, if we go over here to 180, the cosine, which is the x value at 180 degrees, my answer is a -1. Okay, so this time it gave you the formula and you had to condense it. You had to bring it back together and then solve it. The sine is part of your formula that leads to cosine. This whole thing is a cosine formula. In just a second, we'll have one that is the sine formula that also includes cosine. Okay, these next two, that actually ended up being the exact same problem, so I'm okay with us skipping that one. Over here though, 7 pi over 12. Okay, so this one, I'm going to work this one out using the radians. I would highly recommend you guys convert it. But if you think you can understand this, then stick with the radians, because the radians are a perfectly fine unit of measurement. Okay, so I'm going to explain how to do it with the radians, but you probably will want to just multiply by 180 over pi immediately on this. Okay, so with radians, you want to figure out two fractions that are on your unit circle that would add to get that fraction. Okay? Well, if I'm trying to add to get that fraction, I know that my denominator is 12. Right? We know that my denominator has to be 12 because when you're adding fractions, you use a common denominator. Or they can subtract to get that. Okay? But if we look on my unit circle, none of my radians have a denominator of 12. So that means that these are fractions that were simplified to get to the unit circle. So we need to pick numbers that can simplify with 12 to get to the unit circle. So if I chose 1 and 6, the 1 over 12 wouldn't simplify. And so that can't be on our unit circle. But if I chose like 3 and 4, 3 pi over 4, or over 12, and 4 pi over 12, that adds to get this, and both of those simplify to get pi over 4, which is on your unit circle, and pi over 3, which is on your unit circle. So that's how you would do it with radians. Your brain works so much better with degrees, though. I would just get really good at converting. Okay? But that's how we would do it. So here, you might not have pi over 4 and pi over 3. You might have 45 and 60. So it looks like this converts to 105. Did anybody convert that already? It's 105? Okay? But this is your A and your B. So you could still do the same process. Cosine of A, which is pi over 4. Cosine of B, which is pi over 3. We added these together. So we're going to do the opposite in our formula. Sine of A, sine of B. So now exact same process. We go to pi over 4 and we look for our x value. At pi over 4, we have an x value of root 2 over 2. At pi over 3, we look for our x value. At pi over 3, our x value is 1/2. Minus, at pi over 4, we're looking for our sine. So at pi over 4, we're looking for our sine, which is root 2 over 2. And at pi over 3, we're looking for our sine, our y, which is root 3 over 2. And then we multiply just like we've been doing. So root 2 over 4 minus root 6 over 4. So root 2 minus root 6 over 4 is your answer. Again, that looks very similar to all the other answers, but it's flipped, or it's got a negative in a different spot. Okay? So all this work from here down should have been exactly the same if you had converted. It just tells you to look at the angle rather than the radian. But it's still going to tell you to look in the exact same spot. Okay, how do we feel about that? Can we do that?
Yeah.
Okay? Especially with the degrees, I think we can do that. With the radians, it might be hard for you to come up with these two fractions. And by the way, there's other fractions that'll work too. Okay, well that's with cosine. With sine, I guess we don't look at sine yet. Let's look at cofunctions. Okay? With cofunctions, we've talked about cofunctions before because we made fun of Jonah Miller when we talked about them. Okay? You had a test over these things. What do we know about cofunctions? Cofunctions, all you do is you switch your function from a co to a regular. So we switched our cotangent to a tangent. And we have complementary angles. Okay, we have complementary angles. So what is the complementary angle of that 25? 65. Right? 5 makes it 70, and then plus the 20. But let me show you how to work that out actually algebraically. Okay? So if we look at our sheet, down at the bottom here, which we've looked at before, are cofunctions. This cofunction looks like the bottom right of that. Okay? But this says radians, right? That's a pi. We want it in degrees. So instead of pi over 2, we can write 90. So we can write cotangent of 90 degrees minus theta, and make sure to distinguish between theta and 0, equals tangent of 25. Okay? What that shows us is that if these are cofunctions, that means that these are going to be complementary. So 90 minus theta equals 25. Minus 90 minus 90. Negative theta equals negative 65. Divide by negative 1, or just switch your symbols. theta equals 65. Okay, but what you need to remember is that they're complements of each other. They complement each other, they get to 90. Okay, so right here we have sine.
Mr. Madison?
Yes.
I can't see the numbers clearly, so I can't tell if you're putting a plus or a minus between the numbers. In the
It's a minus. I'm just using this formula over here. The
Okay.
only thing I changed is I changed my pi over 2 to a 90 because those are equivalent of each other. So I am putting a minus between those. And then just solving for the theta.
Put the answer.
That is it. That's the answer. Okay, let's try the right side. The right side has asked us to figure out the angle of sine when cosine is negative 30. Some of you might be able to do it in your head. Anybody know what the complement of negative 30 is? Yeah?
20?
Yes. Because that's what makes it end up being 90, right? But let's look at our sheet to make sure of this. So if we look at our cofunctions in the bottom right of our sheet, I got sine, cosine. So we know that sine of theta, that theta is found by doing 90 minus theta. Okay, and again I converted this because both of them are that positive y-axis equals the cosine of negative 30. We can just take the parentheses out because these are cofunctions. 90 minus theta equals negative 30. Solve algebraically. So minus 90, if I subtract 90, that is negative 120. Divide both sides by a negative 1. And we get theta equals 1 to 0.
So technically, if we just do a complement,
That's exactly what cofunctions are, is the complements.
do we even really need to do that?
Nope.
We just know it.
You know it, then you know it. Yeah, that's fine. Okay, it could be that they give it to you a little bit differently though. Like this. So it's still comparing cofunctions, so secant and cosecant. We're still comparing these two things. So what we can do is we can say, well, I know that this has to complement this. That means this subtracted from 90 has to equal this. Okay, so I'm going to leave off one step on this. Instead of writing the formula, I'm just going to go straight to the 90 minus part. 90 degrees minus theta equals this. So 7 theta plus 26 degrees. Okay, be careful. This one, every year, people get confused and start calling that 7. Okay, that's 7 theta. If you need to change it to an x, you can. Okay, now we just solve algebraically. So I'm going to add theta to both sides, just like I would do with x. So 90 equals 8 theta plus 26. See, at this point, a lot of times people subtract 80 from both sides and get 10. So be careful of that. So minus 26 degrees, minus 26 degrees. What's that? 70 minus 6, so 64. Equals 8 theta, and it's going to work itself out well. Divide by 8, divide by 8, and theta equals 8.
How many like chapters are
I don't know.
there? Second,
I don't know. College Algebra 6. Well, we've only done 2 right now. This is not.
This is the third one.
Yeah, we just took forever on that one. All right, so next, I don't have this one written down, so that means it's probably a radians, which means you probably couldn't do it in your head either. It is 3 pi over 4. So if you want to write that one down, 3 pi over 4. Okay, 3 pi over 4 for that. So we got to work it out the same way though. They are co-functions of each other. So if they're co-functions of each other, we can use these co-function formulas. I got secant is pi over 2. We're actually going to use pi over 2 because this one has a pi as well. So secant pi over 2 minus theta equals cosecant 3 pi over 4. So just like we did before, now that we know that these are co-functions, we can take out these functions and get pi over 2 minus theta equals 3 pi over 4. We can solve that a bunch of different ways. You can get common denominators and subtract from both sides. You can multiply to get rid of the fractions, which is always my preference. We can add theta to both sides first, or you can divide by -1 at the end. There's a bunch of different ways. I'm going to multiply to get rid of my fractions. The reason I'm going to do that is because later we'll do that again. So you'll see it again. I chose 4 because that's the common denominator. So 4 times this piece, that's going to be 4 over 2, which is 2 pi. 4 times this piece is a -4 theta. 4 times this piece is just going to cross that out, which is 3 pi. Okay, now we're going to subtract 2 pi from both sides. It makes it a lot easier now that we're doing whole numbers. Okay, that's pi. And then we're going to divide by a -4, divide by a -4, and we get theta equals -pi over 4. Okay, so you could have also just subtracted pi over 2 from both sides. You'd have to get a common denominator and then divided by a -1. That would also get you to your answer. Okay? My preference is always to get rid of fractions, though, by multiplying. So that's what I'm going to do. Okay, so that is cofunctions. Cofunctions tend to be pretty easy, so that means make sure to look over them. Because people tend to miss the easy stuff because they focus so much on the hard stuff when studying. All right, so going back to these formulas, here is the sine formula. We're not going to do as many examples of this one because it's the same thing. You're just plugging it into a different formula. The sine formula starts with sine. Sine starts with sine, but this time it doesn't do sine, sine like the cosine does cosine, cosine. Okay? What I try to remember is that A and B are always going to go in order. So if I did sine of A, sine of B, in order to do the opposites, I have to switch my cosine and my sine because my A is always going to be first. Sine is the same sign, so be careful of that. Okay, we're not going to do very many examples of that. And then we also have tangent. Tangent, like always, complicates things. It's a fraction, so it's going to make things a little bit harder. Okay, here's your tangent formula. Your tangent formula is right here. The top is going to match, the bottom is going to be opposite. And so you can see that on your sheet. It uses plus minus right here, but it uses minus plus right here. Okay, so the bottom will be opposite, the top is always going to match. So we're not going to do very many examples of sine. We're going to go more to tangent because that's the harder thing. Tangent problem will look a lot longer. So stick with me on that. Let's do one sine one real quick. Again, at 75, I'm trying to make those pretty easy for you, but you could also have to grab from different parts of the unit circle. What 2 degrees are we going to use for 75?
45 and 30.
45 and 30. Okay? You could subtract to get to that as well if you felt the need. So 75, so let's do 45 and 30. So sine is, let's do 30 plus 45. If you went the other order, it's okay, because you're just going to multiply those. So the formula is sine of A cosine of B. Sine is the same sign. And then we're going to flip our functions because our numbers still have to be in that order. So now it's going to be cosine of 30.
Would it be minus?
Sine is the same.
Oh, sine too.
Sine's the same sign. Sine of 45. Okay, to make sure I wrote it correctly, I want to make sure I did every degree with every function. I got sine of 30, I got sine of 45. I got cosine of 45, I got cosine of 30. We don't want to match stuff. We don't have the same thing. Okay, now we're going back to our unit circle. Okay, our unit circle, sine of 30. The sine of 30 is 1/2, I believe. I can't see it, but I think it's 1/2. Okay, sine of 30 is 1/2. The cosine of 45, well, everything in 45 is root 2 over 2, so root 2 over 2. The cosine of 30, the cosine of 30 is root 3 over 2, so plus root 3 over 2. And then the y of 45, the y of 45, everything of 45 is root 2 over 2. And again, this will look very similar to all our other answers. Root 2 over 4 plus root 6 over 4. So root 2 plus root 6 over 4. Okay, should be pretty simple because we know how to read the unit circle and we know how to plug stuff into a formula, a given formula. Okay? Any questions on that? Still think we can do that? I think we can. Tangent. Tangent's the one that's going to freak you guys out a little bit. Okay? So, tangent gives me 7 pi over 12 next to it. I want you to immediately convert that. I don't want you dealing with radians, especially on tangent. Okay? So 7 pi over 12. I'm going to erase this and zoom in. What is 7 pi over 12 converted? That's what I need you to figure out. So this was 7 pi over 12. But I'm going to convert that by multiplying by 180 over pi.
105.
It's 105? Okay, good. So we still have very easy numbers. 105. How do we get to 105?
60 plus 45. Right?
Okay, yep. So tangent of 60 plus 45. Let's start with our lower number. 45 plus 60. So we're all on the same page. 45 plus 60. Okay, so tangent is a bigger formula. Here's our tangent formula right there at the top. Okay, so tangent is tangent of A. So tangent of 45. Same symbol, so we're adding, so this is going to be a plus. Tangent of B over 1. So that symbol's flipped, so it means the opposite. So minus tangent of A, which is 45, tangent of B, which is 60. Okay, now we just need to plug everything in. We need to look at our unit circle and start plugging stuff in. It's going to be a little bit harder to plug stuff in because our unit circle is going to give us fractions on fractions.
Is it opposite symbol?
On the bottom is opposite, yes. So we're looking at 60 and 45, right? Okay, so the tangent of 45, so 45 is here. The tangent is your y over your x, right? Your y over your x. So what's root 2 over 2 over root 2 over 2? What's anything over itself? 1. So tangent of 45 is just going to be a 1. Okay? And that's because it's root 2 over 2 over root 2 over 2. Do we want to write that so it's on your notes to look back at? Okay, let's write that down then. Okay? So that's going to be root 2 over 2 over root 2 over 2. Okay? Plus tangent of 60. Tangent is y over x. So what's your y of 60? What's your y value at 60?
3 over 2.
Okay, so root 3 over 2. And that's what's your x? 1/2. Okay, on the bottom we have this 1 that doesn't even need a unit circle for. We already figured out tangent of 45. What's tangent of 45?
2 over 2.
Okay, and again, if you can simplify these in your head a little bit, it doesn't look this crazy. Y'all want me to write this down, so I am, but I would never write this much. So once you get it in your head a little bit, I would try to start writing a little less, because it just looks way more confusing. Okay, so there's our tangents. We can simplify our fractions a little bit. This whole part turns into a 1. Anything over itself is a 1. So on the top is a 1 right here. Over here, if I got the same thing on the bottom, they can just go away. And then I have a root 3 over 1, which is easily written as just root 3. Down here I've got a 1 minus a 1 multiplied by the 2's cancel. Root 3 over 1 turns into a root 3. Multiplying by a 1, we normally don't write that. So this is where you might be able to get to without writing all this stuff down. That looks a lot more doable than this part. So if you can simplify these to 1s in your head, and if you can realize that your denominator is always going to be 2, which means it's always going to cancel, you can make this a little bit easier on yourself too. All right, so this is our answer, but it's not written correctly. Anybody know what's wrong with it?
The 1s can cancel.
No, the 1s can't cancel because they're attached.
Why is it 1 minus? Where's the second 1? There should be another 1.
Are you talking about this one right here?
No, I'm talking about the, so on top it's the 1 minus 2, that whole thing.
Here, wait, let me draw a line so we know where our next fraction starts. Okay, what are you asking?
So on the 2, the square root of 2 over square root of 2 over 2, that is 1.
Yes.
I'm talking about the bottom one.
Okay.
There should be 1 minus 1 then, right?
1 minus 1 times 3. So if you're multiplying times a 1, we just don't write that. That's fine. I'll leave it there though. When I come up here, that's where I'm simplifying it though.
Yeah.
Okay? All right, so the reason this is wrong is because we have a radical on the bottom. So you do have to rationalize the denominator. How we rationalize the denominator is something we've been doing a bunch lately, multiplying by the conjugates. So 1 plus root 3, 1 plus root 3. On the top we have to FOIL, so 1 times 1 is 1. 1 times root 3 is root 3. 1 times root 3 is root 3. So that's going to be 2 of those root 3's when we combine our like terms. Root 3 times root 3 turns into a regular 3. On the bottom, just like with our proofs, it's going to be this minus this squared, and this squared is a regular 3, so 1 minus 3. All that can be done foiling. I'm just doing a little bit of the foiling in my head. And now we just need to combine our like terms a little bit. So I can combine that 1 and that 3, so I have 4 plus 2 root 3 over a negative 2. And we can simplify 4 divided by 2, 2 divided by 2. That ends up being a negative 2 minus root 3. Every tangent answer will look something like that. Every tangent answer will look something like that with different symbols. Okay? So, some of you, I'm not saying everyone, because not everyone can do stuff in their head as much. Some of you will end up jumping straight from here to here, and then almost jumping from here to here. Like, you'll start seeing stuff because they're all the same process over and over again, because you're always dealing with the same looking fractions. Okay? You always have to rationalize, and you're always going to start canceling stuff out. There's one thing that you could run into that would cause an issue. And that one thing is if occasionally you'll have a 1/2 over a root 3 over 2 on the bottom, which would simplify to having a 1 over root 3 down here. what you would do is you'd multiply by the denominator to get rid of your fractions, and then it would end up looking just like this again. Okay? So, was I right that tangent's the worst one? That's terrible. The rest of it, you just kind of just plug it in and see where it goes. Okay? Questions on that? On the completed notes, if you want them on the completed notes, I did not convert it. So it does look like radians here, 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 and here, but everything else will be exactly the same if you want those. Okay? Hey, remember, this one's the easy. This is the easy thing.
Oh, you got all the words up there on the board.
I know, I'm erasing it. Okay? But this is the easy thing. This already gave you the formula, and you're just trying to condense it. You're just trying to make it go backwards. Which formula is this? Is this the sine or the cosine formula? So it's the sine formula. And with sine, we use the same sign. So are we going to add or subtract our angles? Okay? Sine starts with sine. Cosine starts with cosine. So this is sine. Sine is the same sign, so we're going to take these two and we're going to subtract them. So 40 minus 160. So sine of negative 120. And then from here, we go to our unit circle. At negative 120, what is my y value? So negative 120. Careful with the negative, that tends to confuse us. So 120 would be here. But that's positive 120. Negative 120 is the reflection of that. So 120 is down here at 240. So what's my y value at 240? And there's my answer. Okay? I like those ones a lot because they're actually really easy for you. But those, again, are some that people skip because they study the hard ones so much that they forget that easy process. Okay? I don't think we've used a calculator very much, except for converting. We haven't really used a calculator today. So all of this stuff might have potential. Okay, let's see, what do I got? I got that one. I'm going to have you do another tangent. I want you to just try it. It's going to be a lot, so try to stay organized. Try to figure out where your fractions are going to be and simplify them slowly, okay? Try this one out. I know it's a little bit tougher. I chose 120 and 45. That's what I chose. 120 and 45. That means that you might have a negative angle, so be careful on that one.
Can you do that?
You can choose from anywhere on the unit circle.
Just choose any numbers on these?
Anything. Okay, so this is tangent. Tangent of, we said 45 plus 120. So that means that my 45 is my A and my 120 is my B. Okay, the tangent formula.
What'd you get?
The tangent formula is it tangent of A, same sign, tangent of B. Call me out if this is wrong because I'm trying to go from memory. 1 minus, because it's always going to be opposite symbol as above, tangent of 45, tangent of 120. Is that correct?
Sure.
Okay? Tangent of 45, we know that 45 is always going to be the thing over itself. So that whole section, we should start recognizing just turns to a 1. Because that's going to be root 2 over 2 over root 2 over 2. So all that is going to cancel. Plus 120. 120. 120 is y over x. So that's root 3 over 2 over negative 1/2. So root 3 over 2 over negative 1/2. Careful, that negative tends to disappear at this point. We can go ahead and cross out those 2's. And we know that anything over 1 is just itself. So that's going to simplify to a negative root 3. I'm going to know that for below, so I don't have to write all this work again. So then a 1 here. We have a minus. We already figured out that tangent of 45 equals a 1. And we already figured out that tangent of 120 is going to be negative root 3. Okay? That'll help you save time because you work it out twice. So instead, just write your simplification down here. Careful, I saw like 3 different people put plus there instead of multiplication. You're not adding that. If you add that, then the 1's going to mess up. And it's going to add to a 2, and it's going to mess up your answer. Okay, let me rewrite this. 1 minus, because that's negative, so 1 minus root 3 on top of, so again, that's because this canceled and that negative went up, on top of 1 plus root 3, because minus a negative. Okay, we're going to multiply by the conjugate, so 1 plus root 3 over 1 plus root 3. On the top, we're going to FOIL, so that's 1. That's going to be, I wrote it wrong. That should be minuses, right? I was like, that's not going to work itself out. Minus, minus. Okay, so on the top, we're just going to FOIL, so that's going to be 1 minus 2 root 3. And then plus 3. So that's another part that you might be able to skip. In your head, you might be able to say, well, every single time I've combined these, so I might just do that instead of putting a plus 3, because I'm going to combine those terms anyway. Okay? I'll leave it as it is for your notes, but that's another time that you can save time. On the bottom, these are conjugates. That means that all you're going to do is square the first, so 1, square the last, so 3, and put a minus between them. So I'm going to combine these outside 2 terms, so that's 4 minus 2 root 3 over a negative 2. We're going to divide each part by a negative 2, and I get negative 2 plus root 3. There's my answer. Okay? Still a big problem. I will never say that that's not a big problem. I told you tangent ones are harder, but it's a bunch of algebra. You do know that stuff. Okay? You do know that stuff. You just got to make sure that you are organizing your thoughts well. Okay, last thing. It says rewrite involving functions of only theta. Okay, so what they don't like in this one, I'm going to erase this, but what they don't like in this one is that the parentheses have a 30 and a theta. We only want theta. We don't want degrees of 30. That still is cosine with 2 things added. So we have a formula for that. It is cosine A, cosine B, which is theta. Cosine's the opposite, so minus sine A, sine B. So just like that, at the end of every one of these problems, we can simplify what we can simplify. Okay, we can't simplify these theta ones, but we can simplify these. What's the cosine of 30? Cosine of 30, I think that's root 3 over 2. Anybody that has a unit circle in front of them.
Root 3 over 2.
Okay, root 3 over 2. We don't know this though. Minus the sine of 30. Well, if this is root 3 over 2, this one's got to be a 1/2. And then we don't know sine of theta. Okay, now all of our functions only have theta. Everything else is in the correct form. The only thing is we know that these both have a denominator of 2, so we can write them together. So we're going to take them and write them together. So root 3 cosine theta minus sine theta over 2. And there's my answer. That one shows up on the test. Okay? So we saw that this was addition. We saw that it was cosine. We have a formula for addition with cosine. So we wrote down our formula and we simplified what we could. What we could simplify is the ones with the actual degrees in it. And then we just saw that both of these were over a 2. So we put everything over a 2. Okay? All right. Long lesson. I was talking for about 50 minutes. 50. So that was a long time. Okay?
Long lesson.